Figure 3 shows a sketch of a parallelogram PQRS. Given that PQ is 2, 3, minus 4, and QR is 5I, 0, J, minus 2K. Because it's a parallelogram, I know that this is also going to be 2, 3, minus 4. And PS is also going to be 5, 0, minus 2. We need to show that the parallelogram is a rhombus. Well, a rhombus is a parallelogram that has equal sides. So if I can show that the magnitude of this vector is equal to the magnitude of this vector, then those two sides would be equal in length, and therefore all of the sides would be equal in length, and it would be a rhombus. So let's do that. The magnitude of PQ is 2 squared plus 3 squared plus minus 4 squared, all square rooted, which is root 29. Now we'll do the magnitude of QR. So that's going to be 5 squared plus 0 squared plus minus 2 squared, all square rooted, which is root 29. So I can now say, therefore, PQ, the magnitude of PQ equals the magnitude of QR, therefore a rhombus. All of the sides are equal. Part B says to find the exact area of the rhombus. Now, there are lots of different ways you could work out the area of this rhombus. You could split it into two triangles or do some other things like that. However, I'm going to avoid that because I think I would need to round when using the sine rule or the cosine rule, and it wouldn't give me the exact area. So I'm actually going to use a formula for working out the area of the rhombus. If I can work out the length of these two diagonals, I can multiply them together and divide it by 2. That will give me the area of a rhombus. It's not a common formula. You might not have seen it before, where the area of a rhombus is half times the length of the two diagonals. So it would be half the length of PR times the length of QS. Right, PR. In order to work that out, let's get the vector. Just to simplify my diagram, let's get rid of QS for now. Now, P to R is the same as P to Q plus Q to R. So I'll add those two vectors together. So 2 plus the 5 is 7, 3 plus the 0 is 3, minus 4 plus the minus 2 is minus 6. So that's the vector PR. So the length of that, then let's just do a little bit of Pythagoras to work out the length of that line. Seven squared plus 3 squared plus minus 6 squared, all square rooted, is root 94. So the length of PR is root 94. Now let's work out QS. Well, QS will be the same as Q to P, which notices the opposite direction. So that's going to be minus 2, minus 3, plus 4, plus P to S. So we're going to have minus 2, minus 3, plus 4, plus the 5, 0, minus 2. Minus 2 plus the 5 is 3. Minus 3 plus the 0 is minus 3. And 4 plus the minus 2 is 2. Right, let's work out the magnitude of that then, to get the length of QS. So 3 squared plus minus 3 squared plus 2 squared, all square rooted, is root 22. So the length of QS is root 22. So the area of this rhombus is a half times root 94 times root 22. Which gives root 517. And that is the exact area of that rhombus.